demonstrate what color is. I mean, what it really is. It's easy to overlook what makes a color the color it is, or why some things, like glass, appear to have no color at all. Take this pink flower, for example. We don't actually see that the flower is pink. Rather, we see all of the light that's reflected from the pink flower into our eyes. So today we want to answer why some things are red and some things are yellow. But most importantly, why is Ben's shirt blue?
To understand what color is, first we have to know a little bit about light. Most of the light we see starts with the sun. Without sunlight, life on this planet wouldn't exist, at least as we know it.
The sun is a very hot, very dense giant ball of gas. It is so big that the pressure in the center of the sun causes hydrogen atoms to fuse together in a process called fusion. When the atoms fuse together, a tremendous amount of energy is released as heat and light. Because of the density of the sun, it actually takes light nearly 10,000 years to get from the center of the sun to outer space, where it takes just 8 minutes to reach the Earth.
That's fine and dandy, but what about light bulbs, you ask? Light bulbs come from a different source of energy called electricity. Light bulbs are not miniature suns.
We use electricity to excite the electrons in the chemicals that make up a light bulb. Basically, electrons absorb the energy in electricity and run around faster. The problem is, electrons don't like to be excited, so they fall back down to where they were before. This process releases energy as light and heat. Not all light is the same. The way we put numbers into the amount of energy in light is called the electromagnetic spectrum. It's only a very small part of this that we as humans can see. This is what we call visible light, and this is the range of all the colors that we know.
The way I like to think about it is that light is basically made up of these things called photons, which are just points in space. The photons bounce up and down at different speeds depending on how much energy they have. Since they're all light, they all move at the same speed, and as they move, they make a wave. It's the size of this wave that determines how much energy light has and what color we see. Each color of light has a different wavelength, and this is what our brains interpret as color.
By now, you must be asking yourself, what does any of this have to do with Ben's shirt? Well, Ben's shirt is the color blue because Ben's shirt doesn't like the color blue.
Now imagine this sandwich is light and it has every color in it, and I'm Ben's shirt. Now I really hate onions, and when they get put in my sandwich, I pick them out and throw them at everybody near me. Then when all the nasty onions are gone, I eat the sandwich. Then my body turns the rest of the light into heat.
This is the same thing that Ben's shirt does with light. Ben's shirt is blue because it eats all the other colors. All the other colors are absorbed by the shirt except for blue, which it throws back at you because Ben's shirt hates blue.
Have I lost you yet? No? Good, because this is where things get a little bit weird. Light is not actually a color. It is only energy. Blue light is not actually blue. It is only a wave with a specific energy. The reason you see blue is because your brain interprets this energy as the color blue.
The wavelengths of light that are reflected by Ben's shirt makes its way onto your eye. Light enters your eye and is focused onto the back of the eye called the retina. The retina is made up of millions of tiny structures called rods and cones. These rods and cones take the light energy and translate it to an electrical signal that is sent to your brain through nerves. Your brain takes a signal from those rods and cones and interprets them as a color. The color that you perceive is based off the wavelength of light entering your eye.
And so you see, we don't actually see what we see. Colors are nothing more than your brain's perception of a wavelength of light that's vibrating at a fixed frequency. And better than that, since Ben's shirt reflects the wavelength of blue and absorbs everything else, Ben's shirt is really every color except for blue.
a science experiment. You expected to see kind of one line. Is that what you see?
No.
The amplitude of the wave is increased. That's what we call constructive interference.
You might have heard that light is a kind of wave, and that the color of an object is related to the frequency of light waves it reflects. In the retina, there are two different types of light-detecting cells, rods and cones. The rods are used for seeing in low light conditions, and there's only one kind of those. The cones, however, are a different story. There are three kinds of cone cells that roughly correspond to the colors red, green, and blue. And how come you can't detect colors when it's dark?
I guess one of the things you guys are the most curious about is color. How does it work for you? What is it? I don't know. Blue is the water is blue. Cold or ice is blue. The sky is blue. Now, how can the sky and ice be the same thing? That's weird. But what's that? Same color. Same color means two completely different things. I don't get it.